Hello everyone, in this video we'll discuss about array data structure. First of all, what is an array? An array is a collection of items of the same variable type that are stored at contiguous memory locations. It is one of the most popular and simple data structure and is often used to implement other data structure also. Each item in an array is indexed starting with 0. We can directly access an array element by using its index value. Different types of array are there: linear array and two-dimensional array. Linear array is known as one-dimensional array because each element in such an array is referenced by one subscript. Two-dimensional array is a collection of similar data elements where each element is referenced by two subscripts. In 1D array, only one subscript is there. A is an array of integer type and only one subscript is there. And in 2D array, two subscripts are there. First subscript is for row and second subscript is for column. Basic terminology of array. Array index. In an array, elements are identified by their indexes. Array index always start from 0. 0, 1, 2, 3, 4, 5. These are the indexes. And array elements. Elements are items stored in an array and can be accessed by their index. A is the name of the array. And at 0 index element is 2. At 1 index element is 8 and so on. At 5 index element is 23. What is the length of this array? The length of the array is determined by number of elements it can contain. We can compute the length of the array by using the formula length is equal to upper bound minus lower bound plus 1. Upper bound is the largest index of array minus lower bound is the smallest index of an array plus 1. 5 minus 0, 5 plus 1, 6. 6 is the length of this array. In this array, total number of elements are 6. Array data structure can hold multiple values of a single type. Now in this array, all the values are of integer type. Elements are referenced by the array name and the index. A is the name of the array and 0 is the index. And each element is a value and indexing always starts with 0. And the array forms a contiguous list in memory. And the name of the array holds the address of the first array element. Next is, what is the need of data structure? Assume that there is a class of 5 students and if we have to keep records of their marks in examination, then we can do this by declaring 5 variables individual and keeping track of records. But what if the number of students become very large? It would be challenging to manipulate and maintain the data. What it means is that we can use normal variables like v1, v2, v3 and so on. When we have a small number of objects, but if we want to store a large number of objects, it becomes difficult to manage them with normal variables. The idea of an array is to represent many instances in one variable, like int a of 10. Now in this array, we can store 10 elements. Representation of linear array in memory. Suppose LA is the name of the array. The memory of computer is divided into cells and every cell having a address. Computer does not need to keep track of the address of every element of array LA, but needs to keep track only of the first element of array LA. The address of first element is known as base address of an array. Now in this case 1000 is the base address of an array. Using this base address, the computer calculates the address of any element of array LA by using this formula. LOC, LA of K is equal to base of LA plus W K minus lower bound. Now in this case, base LA is the base address of an array and W is the number of words per memory cell for the array LA. If array is of integer type, like int A of 10, now in this case, integer take 4 bytes, then the value of W is 4. K is the index and lower bound is the smallest index of an array. Let's see the example. An automobile company uses an array auto to record the number of automobiles sold each year from 1932 through 1984. The base of auto is equal to 200. 200 is the base address of an array. And W is equal to 4 words per memory cell for auto array. The address of 1932 is 200 and address of 1933 is 204 and the address of 1934 is 208. Then compute the address of 1965. Now how to compute the address of 1965? By using this formula. Base address of an array. Base address is 200 plus W. Value of W is 4. Then value of K. Value of K is 1965 minus lower bound of an array. Lower bound of array is 1932. (200 plus 4), 1965 minus 1932. Result is 33. 200 plus 33 into 4. 132. Then the result is 332. Then the address of 1965 is 332. Next is various operations performed on array. The first operation performed on array is traversing. Traversing means print all the array elements one by one. Print the content of each element of data or count the number of elements of data with the given property. This can be achieved by traversing array. That is by accessing and processing each element of data exactly once. This is an algorithm for traversing a linear array. In this algorithm, data is the name of the array, LB is a lower bound, UB is a upper bound. For example, data is the name of the array and in array total number of elements are 4. First element is stored at index 0, second element is stored at index 1, third element is stored at index 2 and last element is stored at index 3. So first of all, set k is equal to lower bound. The value of k is the value of lower bound. The lower bound is 0. Lower bound is the starting index of an array. Then repeat step 3 and 4 while k is less than equal to upper bound. Now the value of k is 0. 0 is less than equal to upper bound. Value of upper bound is 3. 0 is less than equal to 3. Condition is evaluated to be true. Then apply process to data of k. Data of 0. Element at 0 index is 8. 8 is to be printed onto the screen. Then k is equal to k plus 1. K is 0. 0 plus 1, 1. Again repeat step 3 and 4 while this condition is evaluated to be true. Now 1 is less than equal to 3. Again condition is evaluated to be true. Then apply process to data of k. Visit the element at index data of 1. Then k is equal to k plus 1. Now k become 2. Repeat step 3 and 4 while k is less than equal to upper bound. K is 2, 2 is less than equal to 3. Again condition become true. Then apply process to data of 2. Then k is equal to k plus 1. Now k become 3. 3 is less than equal to 3. Again condition is evaluated to be true. Then apply process to data of 3. Traversing means assessing and processing, visiting each element of array exactly once. Now k is equal to k plus 1. K become 4. Repeat step 3 and 4 while 4 is less than equal to 3. Now 4 is less than equal to 3. Condition is evaluated to be false. Then control transfer to the step 5. Exit from the algorithm. This is the algorithm for traversing a linear array. Let's see the program for traversing linear array. Traversing means first of all input array elements, then after that displaying array elements onto the screen. Let's see the output. Now first of all enter the array size. Size of array is 5. Then enter the elements in the array. Then after processing, displaying array elements onto the screen. Traversing means first of all reading array elements, then writing array elements. In next video, we'll learn insertion and deletion operation performed on array.